can't make a triangle out of that, so this is where we use its reference angle. So Hiram, how would you figure out the reference angle for 315? Kara told us at the start of class how to find it. You remember? We're going to go back to Kara then. Kara, what did you say for a reference angle? What do we highlight? Yep, so I'm going to, good job. I'm going to go to, here's the x-axis, and here's the terminal side. So that's going to be my reference angle. What is a measure of this? How much further did I have to go to make it to 360? 45 degrees. Now when you hear that, you should have bells go off in your head and be like, hey, wait a minute. Why do we like 45? Special right triangles, Kimberly. You've got yours out. Will you raise up your 45, 45, 90? Do you guys all have one of these? You should. I gave them to you and said, hey, do this on Friday. I can now change this into a 45, 45, 90 triangle. So what I'm going to do is, it doesn't really matter at what point I decide to make the triangle, because I know that there's a relationship between the sides. Let's go over that real quick. In a 45, 45, 90 triangle, do you remember what the relationship was between the sides and the hypotenuse? Let's say this side, let's make life easy. If this is 1, what is the other leg? And what is the hypotenuse? Okay. Can we just use those same side lengths, but on here? Sure, but which quadrant are we in? How will that affect our sides? When we were in the second one, it made the x negative. When we were in the third, it made the x and the y. So what about in the fourth? Just the y. Good job. So here's what I'm going to do is I'm going to come down here, and I'm going to say, okay, the x is going to be, we're going to let it be 1. The y is going to be negative 1. Now with the hypotenuse, will it be positive or negative? Good job. It's always positive. I heard someone out there say positive. Because we get it by going a squared plus b squared equals c squared, and if you square a negative, it's always positive. So now, what was the whole point of this? We're trying to find SOHCAHTOA CHOSHA COW. So we're going to go from this angle's perspective, because remember, we're using the reference angle here. So from that angle, this is going to be my opposite, which is my y value. This is going to be my adjacent, which is my x value. And this is going to be my hypotenuse, which we said is what letter now, guys? R. So you can figure out SOHCAHTOA and CHOSHA COW using this, which we came up with, or using SOHCAHTOA CHOSHA COW, right? Okay, let's do this. I'm going to do SOHCAHTOA real quick, and when I say I'm going to do it, I'm actually going to have Hiram do it. So Hiram, what would sine be of theta? And we're going to write this, guys, is sine of 315. Because the angle we're looking at is 315. I know we're using its reference angle, but that's okay. We're still going to write sine of 315. What would you get here? Awesome. Keep going. Cosine. And tangent. Which is just negative 1, right? Because we do negative 1 over 1, we'll simplify that. Alright, let's go down. I'm kind of running out of room, but let's go to cosecant, secant, and tangent. We're going to send that one to Peyton. Peyton, cosecant 315, what are we going to get there? Great, and we'll just simplify that by bringing the negative, like that. Cool, keep on going, secant. Great. And then lastly is cotangent. Yep. Because in this case, it would be the opposite of tangent, but either way, it's still just negative 1, right? Okay, Good job. So what we're seeing here, guys, is kind of what we're building to is we want to take the trig ratios of angles. And you're going to see, we're going to be careful on how we do that, so it's only going to be special right angles. So it could be what? We saw this 45, 45, 90. What's our other type? 30, 60, 90. So when we're looking at these angles, it's going to be designed that it's only angles that will give you reference angles for special right triangles. Okay? So here's kind of the steps we're going to use. Number one, you draw the angle. Yeah, there you go. We're going to then use its reference angle, and we're going to kind of figure out how we could set this up doing a reference triangle, which is going to turn into a special right triangle, and we can fill in the sides as 1, 1 squared 2. Or what were the sides in our other triangle? Do you remember with the 30, 60, 90? Maybe let's refresh our memory. So in 45, 45, 90, what did we say to use the sides as? 1, 1, and square root of 2. Because we said, on our triangles we put x, x, and x square roots of 2. So if this was 7, 7, 7 square roots of 2, right? But we're just going to let x be 1 to make it easy for us, okay? But what about in a 30, 60, 90 triangle? What we said on this was we based it off the short leg and said, let's let that be x. What did we do to the short leg to get to the hypotenuse? We times it by 2. And then to get to the long leg, we times by the square root of 3. That's a 3. Well, let's make life easy, and let's just make this 1. What does that mean the hypotenuse is? What does that mean the short leg is? Okay, you need to memorize that. You've got your triangles that you can fill it in on, but eventually you need to get to the point where you got this memorized, okay? All right, you guys, you're doing awesome. Hang in there. We've just got, I think, a couple more, and we'll call it good, okay? Okay, so now find the following without a calculator. We don't want to use a calculator here. We're going to use those same steps. So first off, we need to graph negative 210. So Lashaya, help me out here. How would I graph negative 210? First off, what does that negative do? When you're graphing angles, normally we go this way, but what does the negative do? There you go. It goes the other way. So let's go through and graph this. So I'm going to go past negative 90. I'm going to go past negative 180. How much past negative 180 do we go? 30 degrees. Thank you, Josh. So there we go. So this is negative 210 degrees. Now, what would that reference angle be? When we've been talking about this before, we said that you highlight the terminal side and the x-axis. Josh basically already told us what it is. What was that angle going to be there? 30 degrees. We like hearing that because that's one of our special right angles. Okay? So what we can do now is draw a reference triangle where it's going to be a 30, 60, 90 triangle. So this is 30, 60, 90. Now I want you to take 10 seconds and try to figure out how the sides are going to be different in quadrant 2. Quadrant 1, they're all positive. When I flip this over and we're into this quadrant, what's going to become negative? Give you 10 seconds to think about it. All right, Micah, how did you label these sides? Yeah, sure.
The opposite side would be the 60, 90, and then that would be 1. And then the bottom side would be adjacent.
Good job. So we make that one negative. Awesome.
And then the hypotenuse is 2.
Always positive. Okay, so great. It's the same side lengths that we saw, except now the x one is negative because we're into the second quadrant. X is negative, but y is positive. All right, so now we want to find sine of this angle. What sides does sine use, guys? Opposite over hypotenuse, SOHCAHTOA, right? So I'm going to do opposite over hypotenuse. What does that give me? Or if I put it in my calculator, what will that be? Hey, let's check that. Let's see if we did that right. Go on your calculator. Before you put anything, click mode. Mode is on the top bar, right next to second. Make sure you're in degrees. And put in sine of negative 210. Does it give you a positive 1/2? Hey, that's pretty cool, right? You're doing trig. Usually you'd think you'd have to use your calculator to figure it out, but you just figured it out without it. Okay, let's go a little faster this time. Now, earlier when we did 5 pi thirds, I was like, let's just do it in radians, but when we're doing this, you're going to want to switch it over. You just took a quiz on this. How do you change something from radians to degrees? Good. Is it 180 over pi or pi over 180? Which one? It's 180 over pi. How do you remember that, guys? There you go. We want to get rid of that pi. So I'm going to do 180 divided by 3 is 60, and 60 times 5 is 300. So 5 pi thirds is the same as 300 degrees. So let's go ahead and graph 300. I start, here's my initial side. I'm going to go past 90, past 180, past 270. And how much further past 270 do we go? 30 degrees. What does that mean our reference angle is going to be here? How much was left over? 60 degrees. All right, great. So what I want you guys to do is I want you to fill in this reference triangle. So this is a 30, 60, 90, and I'm sorry if my picture doesn't look quite as precise as it should. So this is 60 degrees, this is 30 degrees, and that's 90. Okay, I want you to fill in 1, 2, square root of 3, but which one's positive, which one's negative, or are they both, or what? So think about that for a second. All right, this is how I would do it. The cross from 30 is always going to be 1, and that will be positive because it's positive, right? And then across from the 60, that's where we're going to get a square root of 3, but since it's going down, it's a negative square root of 3, and the hypotenuse will be a 2. You guys agree with that? Awesome, okay. Well then, let's go to Brandon. We want to do tangent of this angle. Tangent uses which sides? So what would that be here? Great. Negative square root of 3 over 1, which is just a negative square root of 3. Question?
What if the x-axis be
So this angle, let's check you on that. Okay, so when I drew this angle was 30 degrees, right? Which meant that this one was going to be 60. We always do the reference angle is always the terminal and the x-axis. That will make the difference there, but that's a common mistake, so good for calling me out on that. Okay. Now, was I saying something? Oh yeah, I had something in my head and I almost lost it. How do I check this on my calculator? Because when you plug that in, it's going to give you a big ugly number. Well, then plug in the square root of 3, and it should be the same big ugly number. Okay? Now, we're going to kind of skip the next one, but let's go to these next ones so we get through this, okay? Do you have any questions on this, though? Are you seeing our strategy? You draw the angle, You draw the reference angle in the reference triangle. You put in your sides as 1, 2, square root of 3, or 1, 1, square root of 2. Make sure you know which one's positive, which one's negative. And then whether it's sine, cosine, tangent, cosecant, secant, cotangent, you just find the two sides you're looking at. Do a ratio there. Any questions? Awesome. You guys are great. Okay, now it's going to get a little bit tricky here. And you're like, what? But whatever. Let's just read this. Angles whose terminal sides lie along one of the coordinate axes are called quadrantal angles. You're like, what are you talking about? This would be things like 90 degrees, or 180 degrees, or 270. They're not in a quadrant, they're in between quadrants. They're right on the border there, okay? Now, the problem with this is, can you draw a triangle using those angles? They don't really make a triangle. So how are we going to figure out SOHCAHTOA CHOSHAW if it doesn't make a triangle? And this is when you need to refer back to this. That if you're asked to find sine, you're going to do y over r. If you're asked to do cosine, it's x over r. Tangent is y over x. And let me show you two examples of this, okay? So let's say I was asked to find the sine of negative 270. Do you guys graph negative 270? Yeah, let's hurry and do it. Okay, so here's my positive, this is my initial side. Since it's negative, we're going the other way around. And basically, where do we end up, guys? 90 degrees, okay? Now, what I'm going to do on this to make this a little bit easier is let's just pick a point here, okay? I'm going to call this point 0, 1. Now, we're not going to draw a triangle, but let's think about what would the value of x be, what is the value of y, and what is the value of r. If we're just looking at this point right here, does it go left or right at all? Is there any x value here? No, there's no x value here. What is the y value going to be? 1. And if this were a triangle with a hypotenuse, what would it be? Well, it's going to be the same as the y value, right? The r is also going to be 1. Okay, now we're asked to do this sine of negative 270. So we need to do sine, and we're used to sine being opposite over hypotenuse. But how did I say to think about it now? The opposite is that x or y. That's y, right? So the opposite is y, and the hypotenuse is r. And if you go back and look at your formulas, you'll see that. But this is going to be y over r. What did we say y was? And we're going to divide by r, which is 1. And 1 over 1 is 1. Now, you can check that real quick on your calculator. Sine negative 270. Put that in and see if it gives you 1. Did it work? Awesome. Okay, let's go to tangent of 3 pi. I want you to turn to your neighbor and figure out where is 3 pi. See if you can draw that out super fast. You need to turn. You can turn to the camera and tell the camera where 3 pi is, Hiram.
So it would be 90.
Hey, Brinley, where's 3 pi?
Yeah.
Yeah, we'd go 2 pi and then right there. Now, let's do this same strategy here. Let's just pick this point right here that's 1 away from the origin. This would be the point negative 1, 0, right? Now, we're going to say what is x's value, what is y values, and then what is the r value going to be, okay? So, x value, here we can see x is what? Negative 1, right? On the last example, x was 0, but on this one, x is negative 1. What is the y value going to be? 0. Now, the r is a hypotenuse. Basically, we could do the Pythagorean theorem here to get it. Negative 1 squared plus 0 squared is 1, and what's the square root of 1? 1. The r will always be positive, even if x or y is negative. Okay, now we were trying to do tangent here. So we're doing tangent of 3 pi. What sides does tangent use? Opposite over adjacent. But we're going to switch our thinking, and opposite is y, and adjacent is over x. So if I do y over x, I get 0 divided by negative 1. What is 0 divided by negative 1? 0. It's okay if 0 is in the numerator. What can't we have? 0 in the denominator, alright? Now, let me hurry and check time, because I see people walking there, everyone's like, wait, hey, they're out like 7 minutes early. We're like, calm down. Let me hurry and do 11 pi halves, okay? So here is 1 pi half, 2 pi half, 3 pi half, 4 pi half, 5 pi half, 6 pi half, 7 pi halves, 8 pi half, 9 pi halves, 10 pi halves, 11 pi halves. Holy cow. That was a lot of rotations. But now, how are we going to think about this point? This is a point 0, negative 1. So what is x? 0, thank you. What is y? Negative 1. And what is r? Just want to be 1. Good job. Now, if we're doing secant, so this is where you got to think SOHCAHTOA, CHO, cow. This is sha, right? So that is your hypotenuse over your adjacent, but we said your hypotenuse now is your r, and your adjacent is your x. And if you have to refer back to the formulas, you're great. Don't worry about it. But guys, look what happens here when I do r over x. I get 1 over 0. What happens when you divide by 0? Bad things. So we write this as undefined. And that's how you get, sometimes you're going to put in trig ratios, you're going to see it, it's undefined. What that means is it's a quadrantal angle that's dividing by 0. Alright, last page here. We're going to do this, we're just going to do a couple, maybe 1 or 2 from here. But the idea on this one, this is good, okay? So, let me just do it. Sine of theta is 3 over 7, and tangent of theta is less than 0. So, I need you guys to think. Sine uses which sides? Opposite over hypotenuse. Now, I'm told that the opposite is positive and the hypotenuse is positive. So in which quadrants is the opposite, which is your y value, positive? 1, y is positive. Where else? 2. So I could draw this triangle in 2 different places, okay? I could draw this over here. So this is opposite is 3 and the hypotenuse is 7. So it could look like this. Or where else could we see this triangle? In the second quadrant, because I could have 3 and I could have 7. Okay. Now, what this is saying is we want to find a cosine of theta and the tangent of theta based off of the data. Well, we don't know if theta is here or theta is there. Because this first piece of information, I just got that. But notice here, what does the second piece of information say? Tangent is less than 0, which means tangent is what? Negative. What sides does tangent use? Opposite over adjacent, which, if I did opposite over adjacent here, am I going to be positive or negative? You'd be positive here. Is that what we want? If we came over to this side, so we know that this side is going to be negative, would that make your tangent less than 0? Yes. So that means I'm not using this one. I'm going to use this side because I know it'll be negative. Now, how are you going to figure out what this side is? I only know 3 and 7. How do you figure out the other side? Pythagorean theorem, a squared plus b squared equals c squared. Once I get that, can you then do cosine and tangent? Yes. I'm going to leave it there. You can do that. Let me just show you another one super fast here. If secant is 3, what sides does secant use? Well, this is CHO, CHA,